to Mechanical Pros. I'm John. I'm here with my friend Patrick with Riello. We're talking about boilers again, how the Riello is different from other boiler designs. We're bringing in boiler professionals and we're going to kick the tires and go through real life scenarios of why boilers fail and how the Riello Array can help with that. With that, I'm going to turn it over to you, Patrick, and then we'll bring in our boiler pros.
Riello Array is a multiple heat engine platform. What we're going to do is, just quick review. Multiple heat engine platform, the heat engine, fired heat exchanger with a circulating system, autonomously operated. Each of these heat engines operates regardless of what's happening with the other one. With the multiple heat engines in the same cabinet serving the same system, it's nearly inherently redundant. It's not fully redundant, it's nearly inherently redundant. There are some controls and safety devices in the cabinet that are common to all the heat engines. The trick, if you have nothing else to do one evening, is download the installation and operation manual and look at the wiring differences from the managing controller and the dependent controllers, and you'll see there are some controls and safety devices that land on the managing controller. The managing controller then doles out those go signals, if you will, to the other controllers so that the other Helix heat engines know that it's safe to operate. Case in point, each of the heat engines do not have their own maximum minimum gas pressure switches that help us to have confidence that the gas pressure is at least in an operable range. Those reside here on the common gas manifold. The failure of one of these switches would be reported through the managing controller to the dependent controllers that we are concerned that either we have an over gas pressure scenario, or in the absence of over gas pressure or excessive gas pressure, this switch has gotten flaky and has given us trouble. A flaky switch given us trouble would need to be replaced. Regrettably, in the case of this flaky switch, the unit would not operate. Because there are only single points of failure on the cabinet, we can have those parts on hand to resolve these single points of failure and restore operation. I was told last week by a technician that probably the second, third, fourth time they did something like this, it would take about 20 minutes. The first time, it might take them 30 minutes to swap out one of these single points of failure. And so that's the quick little recap on what we're doing with Array and the premise of this conversation, which is to spin, if you will, the wheel of failure and see how much capacity we lose if a problem happens to the Array.
So let's bring in our boiler pros, kick the tires with them.
Let's kick the tires, see what happens.
Let's ask some real life questions. All right, turn it over to you, Patrick.
Thank you. Kevin, I'm Patrick with Riello.
Nice to meet you.
Good to see you again. Kevin, if you could, you are a boiler technician. You work on boilers.
That's correct.
Technically, okay, good. Not just a humble peddler like myself. You've been out on some calls where you've had some boiler failures.
That's right.
If you could, what are some of the recent problems you've ran into one at a time? What was a problem that you got called to resolve on a boiler?
The most recent one, probably the most common one, is failed to ignite. Probably failed to ignition.
Failure to ignite, okay, an ignition failure. Okay, good. If we could, let's do that. Let's throw this fault at the Riello Array and see what happens. Okay, failure to ignite. So that's going to be ignition system. We're going to need some gas, we're going to need some air, and we're going to need a spark, right?
Sure.
Here, just real quick, what we have is we have gas entering the combustion system here. We need air that's coming through the cabinet being drawn by the blower, and then we're going to spark it with this device off of the ignition transformer, and we're going to prove that flame with this flame rod. Typically, where does that problem manifest? So the problem is it won't ignite.
Right.
What is the problem that you had the part you had to fix last time?
It was a ultraviolet light detector.
A flame scanner, flame sensor,
yeah.
The device that senses the flame once it's established. And in that case, that would be this component here.
Yeah.
Okay. In the case of Riello Array with the multiple heat engines, this Helix has its own ignition system, its own flame proving, and this Helix has its own ignition system and its own flame proving. So in the case that you went on, Kevin, where you had a failed flame proving system, for example, it would occur here on Helix number 1, and we would lose this heat engine. Like you lost or you were intermittent losing that particular boiler.
Right.
How much capacity was available with that fired heat exchanger, that boiler, when that ignition problem occurred? How much capacity did it have out of that box?
2 million.
2 million BTUs, and it was down, all 2 million BTUs.
Right. It had actually two heat exchangers, and because one failed, it completely shut. Oh, it didn't have redundancy.
It didn't have redundancy, so it was a dual heat exchanger system. However, the failure of one caused the failure of both.
Right.
Interesting. Okay, so in this case, the failure of this particular device is going to take down this helix. This helix is not going to know it's going to continue to operate. And so we would have 50% of the capacity available, whereas they had 0.
Yeah, they went to 0. Yeah.
They went to 0. How did that impact that site? Was it okay? Were they not too concerned about it, or was it important to them?
No, it was pretty important to them.
It was pretty important to them.
Yeah.
Had they had half of that machine continue to operate, or if they had the array
Right.
and had operating heat engines, whether it be 1, 2, 3, 5, or 7
Right.
heat engines continue,
They could have got by, and they may not even notice it.
they may not have noticed it. It was a trouble call, it was a fail call. Was it an emergency call?
Yeah, they put it in as emergency.
They put it as emergency. So did you go on hour or off hour?
It was during business hours.
It was during business hours you were able to go do it. But you prioritize that ahead of other
Sure.
maintenance calls or other situations. And they were probably glad to see you.
Oh yeah.
Okay, so that's one situation, an ignition problem that we threw here at the array, and we would have continued operation. Is there another problem that you've dealt with recently that?
Water flow issues.
Water flow issues, okay, and how did that manifest with the unit?
Basically, the paddle switch wasn't making to indicate that water was there to.
Okay, so you had a fired heat exchanger, a boiler, that was having flow issues, and it was being indicated because the flow switch was not making.
Right.
Rather than having a flow switch that proves flow on this appliance, what we do instead is we have a flow meter. What the flow meter does is it gives you a readout in gallons per minute, or if you prefer metric, you can do liters per second, and it's going to give you that input. And for that thing to have a problem, that it would have to clog or otherwise, or have a bad output. The flow meter exists on each heat engine, and so in that case of a failed flow meter or a flow switch, the whole fired heat exchanger went down.
That's right.
You had 0 capacity of the unit that was installed. In the case here, because the flow measurement, the flow proving exists on each of the heat engines, that failure of our flow meter here, let's not pick on helix number 1. Let's say helix number 2 had a failed flow meter. Helix number 2 goes down. Helix number 1 continues to operate. Helix number 3 would continue to operate. 4, 5, 6, 7, 8 would continue to operate. We would only be down that specific heat engine capacity. Okay, so that was a flow-related issue. What's another issue, Kevin, if you could, that you've ran into? We've had ignition issues. We've had flow issues. Is there something else?
Just poor heat exchange. Basically, the tube's getting basically corroded or dirty.
Okay, you have a situation where the heat exchanger is beginning to become worn. It's been poorly maintained by somebody else.
Right.
Just over time has taken its toll, and that manifests in eventual failure or compromised capacity.
Right.
Failure, of course, would be a bad thing. You would lose the total use of the appliance.
Mm-hmm.
In this situation, what we would have is each of the helix units, each of the heat engines has its own fired heat exchanger. That heat exchanger challenge would reside in helix number 1 or helix number 2 because they don't operate together all the time. They operate in a sequence. And so over time, if helix number 2 had been neglected, you'd lose helix number 2, and the other helix heat engines would continue to operate. In that situation, when you lose a heat exchanger in a traditional boiler, you have how much capacity? How much of that unit is available if you fail the heat exchanger?
Right, you lose it all.
Lose it all.
Right.
In the case of array, with the multiple heat engines, if this one fails, they continue to operate this one. Let's do this. Let's just go a little bit deeper. In the event that this one fails and you have to work on it, where did you have to work on that unit? When that unit has a failed heat exchanger, if they want to replace it, where did that work have to occur? In the mechanical room?
Right, yeah.
Okay. Comfortable place to work, or are they sometimes good?
No, usually pretty uncomfortable.
Usually pretty uncomfortable, hot. Okay. Good news. Kevin, if you happen to have a failure of a heat exchanger or a suspected failure of a heat exchanger, this comes out and can come here to the shop to be worked on. Okay, given the choice, let's say, Kevin, that you're the typical boiler technician. Given the choice of working on a heat exchanger at the site or taking it to the potentially air-conditioned shop to work on it, where would you prefer to fight that heat exchanger battle?
I'd rather do it inside the shop.
Do it in the shop.
Not just for comfort, because more availability of tools or parts or whatever.
Kevin doesn't have to be comfortable when he works, but he's going to have a better chance to do a better, more thorough job if you bring it to the controlled environment of the shop and get to work on it. Okay, Kevin, that's really what we wanted to do here. We spun the wheel of failure 3 times. We've had 3 situations where the entire capacity was either taken down or thoroughly compromised on those boilers.
Yeah.
And here what we've lost is part of the capacity. It's continued to operate, and it's proven to be potentially easier to work on. Kevin, I appreciate your time.
Sure. Thank you.
Thanks, Kevin.
What we're going to do is talk a little bit about the wheel of failure and some boiler failures that you've encountered on your calls and how they would have affected the Riello Array. If you could, what are some of the recent boiler failures that you've encountered when you've been called to work on a boiler?
Last one was low water cutoff failure because the boiler was probably 2 million, and it was a 15-to-1 turn down, but they couldn't figure out what was going on, and it turned out to be that there's a couple of models like this. They use one element to get rid of air.
Low water cutoff challenge.
Yes.
Okay, if we could, let's open the, so then you can jump in front of the door here, Tommy. Tommy, good news. Now, when you had the failure, the low water cutoff failure on that particular boiler fired heat exchanger, you went from having some heat available to how much heat available?
0.
0 heat available, okay. Riello Array, redundant low water cutoffs. Now, we're gonna have an opportunity to have that low water cutoff challenge here, or here. These are independent low water cutoff probes. There is a low water cutoff that exists back on the common manifold. So we're going to have a couple of opportunities to introduce a low water cutoff challenge. If the low water cutoff failure was the device.
There was air stuck in the top of the heat exchanger.
The air stuck in the top of the heat exchanger. Okay, that could occur at 3 different places on this appliance, in fairness. If it occurs here, or here, because of perhaps the failure of this air vent to operate, that's going to airbound, and that's going to result in this low water cutoff tripping. If that occurred here, it would not occur here, and we would have at least some capacity available with the array. If it occurs back on the header and takes on that low water cutoff, we would have a common failure and we would have no capacity. So depending on where that air existed in this system would depend on how much capacity we lost. We do have, unlike maybe that appliance was a little different, on each of the heat engines where the hottest water is going to be produced, we have a point of air elimination. And so it would follow that perhaps the failure of this air elimination or outrunning its ability to eliminate the air might cause there to be air present here rather than water, which would in fact accurately trip the low water. In this situation, we would lose one of the heat engines rather than multiple, and you would have some capacity available. So I'm going to say that in this case, it would be a potentially single heat engine failure, or if that occurred back on the header, we might lose the entire thing. Tell me about another failure that you've had to go address.
Primary pump failures on the boiler.
Primary pump failure on the boiler. Okay, so in that situation,
You're down.
You're down. Okay, so you're going to have a boiler, a pump associated with the boiler in order to operate.
Yes.
Okay, and we do the same thing here. The heat engine concept of having the fired heat exchanger with the circulating system, each of the Helix heat engines has its own circulator, but each does have its own circulator. So in the case that you dealt with, there was a failure of a circulator.
Yes.
It took down the full capacity of the connected appliance.
Yes.
Okay, good news, good news. If that happens with Array, you lose the capacity of one of the heat engines because they each have their own circulation. Now, was that unit was down for lack of circulation? Were either of those situations with the low water cutoff or the circulation, was that a crisis? Was it a thing that they could let go?
No, it had to be taken care of immediately. And the whole thing is if you trip the relief valve, and we have I've seen 3 models do this of other vendors, that they'll collect air in the collection circuit, depending on how the boiler's piped. And the sensor will trip low water. You walk up to the relief valve, you just pop the relief valve, let the air out, and away you go.
Away you go. Okay, they're a little different in that they don't have, at each point of,
No,
at each point where you're going to have the most air made available, free from the water because of inverse solubility, et cetera. We're not going to get into physics. We have these air vents. So we have an opportunity to fend off that issue that would require a failure at the helix level to resolve. So circulator, you were down, you had to get a circulator.
Yes.
Hopefully it was a very common circulator.
No.
It wasn't. Okay. We use a Grundfos circulator off the shelf. I don't know how common Grundfos circulators are in this market.
Around here they are. They're available.
Okay, so you would either have one working on an array, or you likely would be able just to pick one up.
Yes.
Is there another recent failure that we can throw at the array?
Flame safeguard.
Flame safeguard. Okay, so the flame safeguard on these units, we're not going to take the door apart, although I'm sure Tommy would be game to do so. And we have technicians watching that would love to see what's going on behind this door. But flame safeguard, all the sequencing and control is happening behind this door with a controller that it happens to be identical to this one. It just doesn't have the screen and the push buttons. But this controller is managing the operation, the flame sequencing, etc. So what I'm saying is that each of the helix heat engines has its own flame safeguard management system.
Mm-hmm.
So in the case of a failed flame safeguard, we would lose the capacity of a single heat engine. How much capacity do you lose when you lose the flame safeguard on a conventional boiler?
Everything.
You lose the whole thing. Okay.
Yeah, it doesn't matter if it's 20 to 1 or 10 to 1 or 15 to 1 because you have no redundancy.
You have no redundancy. The loss of a flame safeguard is the loss of the unit. Okay. Was it a readily available flame safeguard?
Right now we're having problems with certain flame safeguards getting the parts. They're not readily available.
Okay, there's some. And so these are older. I'm not going to pick on that too bad. Everybody's having supply chain challenges. However, the difference between that situation where they were down because of a flame safeguard completely would be different than if we had a 1 of 2, 1 of 3, 1 of 4, 1 of 6, or 1 of 8 down. Your customer would at least have some heat to get through.
Yes.
Outstanding. Gosh, so now we've thrown a variety of issues. We spun the wheel of failure 3 times. Tell me, any questions, any comments, any concerns about Array now that we're standing in front of it?
No, it's nice to have independent gas valves too.
Independent gas valves, and what we're referring to is each of the heat engines uses its own gas control valve, its own blower, et cetera, ignition system. We talked about that previously with Kevin. I'm saying you're stopping by to spin the wheel of failure with us. Outstanding.
Patrick, thanks for talking with Tommy and Kevin. So you guys went over some failures. What did we miss?
What we missed was we had 3 failures that we couldn't talk about with good visibility from the front of the appliance. As I recall, one was a flow switch. We had a unit that had a bad flow switch. The lack of being able to prove flow resulted in the loss of the unit, the entire capacity. What I responded with was, we do prove flow on each of the helix heat engines. The helix heat engine, the fired heat exchanger with a circulating system. We prove flow continuously on each unit with a flow meter, not a flow switch. Okay? The jury may still be out with, is the flow meter going to have as much, less, same amount of trouble that a flow switch has? I'm going to lean towards the flow meter, but the point is this. Any challenge that you would have with this flow meter is isolated to the heat engine level. He had a failure of a flow switch, which is a digital device, not an analog device, that failed to give him a go signal to run the entire fired heat exchanger. When that happens to Array, it would happen to the flow meter, which is not a flow switch, but it would occur at the helix level, and the additional present helix heat engines would continue to operate. We also had a low water cutoff challenge where the system got some air in it, and it was detected by the low water cutoff because it became airbound, and since there was air there where there was not water.
This here's our low water cutoff.
That's the low water cutoff that we referenced. We talked about the fact that each of the helix heat engines has its own low water cutoff, And to evade the collection of air, we have the automatic air vents present near those low water cutoffs. However, if through operation some air accumulated and became trapped up in the common header, and this low water cutoff tripped, this low water cutoff input would take down the entire appliance. So we have, in fairness, we have more opportunities to have a low water cutoff event. However, the event that the situation that led up to the failure was air accumulation that we probably addressed better at the helix level with Array. However, had that occurred here, we would have had the loss of full capacity, which would have made us equivalent to that unit. So that was the one that could have gone either way, that we would have been as bad rather than much better off with that failure on Array.
So basically airlocked, shutting off the whole system.
Airlocked,
Yeah.
yes.
Gotcha.
We talked to Tommy and Kevin about failures that they had and how they had addressed them. One of the failures that we weren't able to address from the front of the appliance was a circulation failure. The fired heat exchangers have got to have a method to move the energy from the fired heat exchanger to the system where the energy is desired, out in the building or in the pool or the hot tub or the hot shower, whatever it is. That energy doesn't travel wirelessly, it travels via the water, and the water's got to get pumped. That circulation is very important. We had a challenge with a flow switch where the flow switch wasn't indicating that it was occurring. We also then, Tommy had been on a call where the circulator had failed. So it wasn't a bad switch, it was actually, they had no flow. And we discussed the fact that that circulator was not readily available and he had to bring it in, and that all of the capacity was down while that circulator was failed. We circulate water as well. The heat engine concept, we do that from the factory. We're gonna flow the fired heat exchanger with a circulator. Each of the heat engines has its own circulator, and they're here. I mean, everybody's familiar with the Grundfos circulator. They're very common, they're very prevalent. In that situation, the failure of a circulator would have taken down a single heat engine, and the other heat engines would have continued to operate, which in that case, the spin of that wheel of failure had left Array at partial capacity, whereas it left that specific boiler down completely. Total lack of capacity. The other thing that we discussed was the fact that circulator regrettably was not readily available. However, this Grundfos circulator probably would have been available, very readily available circulator, as are the other components. We pride ourselves in doing non-proprietary, readily available components, so you don't have to come to us for pieces and parts. So that's how we addressed it. So on balance, with the exception of the low water cutoff, every situation that Tommy and Kevin had encountered in the case of Array would have left us at partial capacity and not been the crisis that loss of the entire boiler system, the entire boiler capacity on those calls took them down and kept them down until parts became available.
Yeah, that's great. So Patrick, non-proprietary parts, multiple levels of redundancy.
Yes.
We can keep parts in stock. We can keep circulators. We can keep the control panel. The same parts fit every array.
But they fit every size of heat engine, and so
Right.
this is a fun one because of our introduction with the single heat engine platform. Obviously, the single heat engine platform, because it's not multiple heat engines, each of those situations that Tommy and Kevin encountered would have been failure of the entire capacity. However, once we get into Array, the multiple heat engine, we have that opportunity. But the point is this: for the 399,000 BTU heat engine, one circulator fits all. One blower fits all. So once you have, or an owner has, a blower for a 399, a blower for the wall-mounted 256, or a blower for the 500,000 BTU heat engine, you have all the parts you need to address any one of those heat engines, regardless of how many or how few are in a cabinet and regardless of where it's located. And so that's kind of the magic.
That's it.
Behind Riello Array.
That's the magic. And we got the parts in stock.
We got the parts in stock. Outstanding.
Great to be with you, Patrick.
John, always good to be
Great
here.
to talk boilers. Come
Always.
back anytime. Hit that like, hit that subscribe, come back, check us out on Mechanical Pros.